Hi, in this video, we want to talk about the multiplication of vectors. Previously, we looked at the concept of vectors where we talked about the meaning of vectors. We looked at the application of vectors in physics, that is, the need to study vectors as far as physics is concerned, where we talk about two different quantities, the scalar quantities and the vector quantities. We moved forward to talk about the addition and subtraction of vectors, where we looked at three different principles to add and subtract vectors. That is, a triangular vector addition, a parallelogram law of vector addition, and also resolving vectors into its various components. For this video, we want to talk about the multiplication of vectors. For multiplication of vectors, we have two types of multiplication. The first one, which we are going to be looking at for the sake of this video, is the scalar multiplication, otherwise known as the dot product. Then in a subsequent video, we'll talk about vector multiplication, otherwise known as the cross product. What is the difference between both? For scalar multiplication, when we multiply two vectors together, our answer would be a number, a scalar, just like the name implies. The scalar can be positive, can be negative, can be zero. But when we want to multiply two vectors together and we want our result to be a number, a constant, then we have to carry out the scalar multiplication or the dot product. Why for the vector products? As the name implies, when we multiply the two vectors together, is going to result in another vector. So we have various applications across science and engineering, depending on what we are trying to do or trying to achieve. Now, let's say we have two vectors, vectors A and vector B. From resolution of vectors, we know we can write these vectors into its various components. That is, a vector can be written as A of x I plus A of y j plus A of z k. B vector can also be written as B of x I plus B of y j plus B of z k. Now, when we want to carry out the scalar multiplication, that is A vector dot B vector, what does it mean? First and foremost, we must know that in order to carry out dot product, or in order to carry out dot product, there are two things that we should know or that we should note. Number one, the two vectors must be starting from the same point. They must be starting from the same point, and then the angle, there must be an angle between them. If they are not starting from the same point, then we can carry out dot product. As a result of starting from the same point, then definitely there will definitely be an angle between them. What are we trying to say? So let's say this is still our vector A, has been drawn like this. I'm having vector A here. If I were to say this is vector B, for me to carry out A dot B, then I must move B up or bring A down. So let's say we do move B upward in this direction. So remember, we said for vectors, we can move them across any part of our plane in as much as we maintain its magnitude and also its direction. Now, if I move B up, then this becomes my B vector. I can see that between B and A, there's an angle between them. And this angle, I can refer to it as theta. Now, make no so you don't be confused. Of course, we've been looking at the concept of directions where we talked about the reference angles, the polar angles, and so on and so forth. This theta here is simply the angle between B and A. It doesn't account for any form of direction. It is not our reference angle. It is not our polar angle. It is not direction of B. It is not direction of A. It is simply the angle between A and B. Now, if that is true, then we can now look at the meaning of dot product. When we want to carry out dot products, what we are basically saying is we're trying to find the product of the magnitude of A with the projection of B on A. I repeat myself. When we're trying to find dot product of two vectors, we're now saying it will be the product of the magnitude of A multiplied by the product of the projection of B on A. You can just think about this as if a light is being shown at this angle. Maybe I'm putting on a flashlight lamp or an headlight at this stage. Now, if you put the flashlight at this stage here, this B will have two shadows. To have a shadow like this, then to also have a shadow that is parallel to A. So which of the multiplications are we looking for? Of course, this is B. This would be Bx. This should be By. From what we said A vector dot B vector would be equal to the magnitude of A multiplied by the magnitude of B, or the projection of B on A. And the projection of B on A is simply Bx. Now, we know from trigonometry and of course from our previous video that this Bx, another way for me to write it, will simply be, so this is A magnitude dot B cosine theta magnitude. And this is A vector dot B vector. Now, what does this mean? It means, remember, when we started, we said when we take the dot product of two vectors, our answer will always be a scalar. The magnitude of A is a scalar. The magnitude of B also is scalar. Cosine of any angle is also a scalar. So when you multiply constants together, the answer will still be a constant. So we can write this and say A dot B, A vector dot B vector will simply be equal to A magnitude, B magnitude, then cosine of the angle between them. I hope this makes sense. All right, we'll come back to this later on, but let's move on to the left-hand side, what we've written, vector A and vector B. How do we now multiply these together? And let me just clear this down part. Okay. All right. Now, A dot B. Remember, when we have a bracket, let's say we have A plus B, then C plus D. We're going to multiply this A by C, then A by D, then B by C, B by D. Basically, we're distributing one bracket over the other. So that's the same thing we want to do here. We want to distribute vector A over B. And by distributing vector A over B, we'll have 9 different quantities. Because, yes, we have AXI multiplies BXI, AXI dot BXI, okay? And then we have AXI BYJ, AXI BZK, AYJ BXI, but we're just going to be taking samples. The reason we're taking samples is that our results or our answer will be so clear, so we don't have to take all the whole nine operators that we're going to be generated when we distribute vector A over vector B. But for the sake of this, let's just take two. So we're taking I and I, and let's take AZK. So dot 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 dot. So plus AZK, then multiply by BYJ. So doing by doing this, we can come to a valid conclusion. Now remember, from our previous video, resolution of vectors, we know that this AX, AY, AZ, the whole magnitude or scalars. So if I have AX multiplied by BX is also a scalar. Remember, this way of writing vectors, we want to separate the vector into its magnitude and its direction. So AX, BX, they're scalars. So this one, I can say AX, BX for this first one. Now, I have I here and then I have I here. Remember, the magnitude of I, like we said, is 1. Of course, I is a vector, but the magnitude is 1. Now, if you come here, I want to do I dot I. So I'll assume that the first I will be my A, the second I will be my B. Now, if I come here and then say, so the magnitude of I, like we know, is 1. The magnitude of this I is also 1. Now, the angle between I and I, remember we said I is a vector that is purely on the x-axis. So the angle between these two vectors will simply be 0 because they are parallel. So if they're parallel, they are not touching. So, and then the angle between them will then be 0. So this is cosine or cos of 0. Now, cos of 0, we know that will give us 1, magnitude of 1. So this is simply 1 times 1 times 1, and this is simply equal to 1. So when we say I squared, I think I remembered in our previous video, when we were squaring I, and then I made a mention that when you square it, it returns just a value of 1. So this is where we got that from. So instead of writing I here, so since it is already 1, then I'll just have AX, BX. Now, if I dot I is giving me 1, it must mean that J dot J will also give me 1. K dot K will give me 1 also. So I've taken 3 of those components outside, remaining 6. Now, for the remaining 6, let's do the same thing here. So if I'm having AX, BX, definitely I should have AY, BY, and also I should have AZ, BZ. Okay. Now, for these two, this is AZ and BY. So, of course, we know if we multiply them together, it's just like multiplying two numbers together. But let's worry about the vector part, K and J. So again, I write K here, then dot J. So magnitude of K, we know it is 1 because it's a unit vector specific to the z-axis. Magnitude of J is also 1 because it is a unit vector specific to the y-axis. Now, what is the angle between K and J? Remember we said I and J, the angle between them is 90, perpendicular. I and K, the angle between them is 90. K and J, the angle between them is 90, our 3D, our three-dimensional plane. So if the angle between K and J is 90, so we know that this will be cos of 90. Now if this is cos of 90, this is 1 times 0. So K dot J returns 0. That means the other 6 combinations we have, that is the mixture KJ, IJ, IK, Ki, and so on and so forth, will all return in 0, hence leaving these 3 these 3 operators as my result. So when we want to take the dot product of 2 vectors, 2 or more vectors, multiply the i's with the I, multiply the j with the j, multiply the k with the k, and discard the I, J, and K because this will result in a number. So the final answer here would definitely be a number. Now, before we move on to taking an example, what if you are being asked to find the angle between two vectors? If you are now being asked to find the angle between two vectors, what do we want to do? So basically, we'll just equate these two operators together. So equating them, I know that A dot B is given as A vector or the magnitude of A vector multiplied by the magnitude of B vector multiplied by the angle between them. That is what we've written here. Now, for us to get the angle between two vectors as far as dot product is concerned, we can simply say since A dot B vector is given as this, A dot B vector is also given as this, then why not we equate these two equations together and then make theta the subject of our formula. So we can say A B cos theta must be equal to AX BX plus AY BY plus AZ BZ. And then cos theta will be equal to AX BX plus AY BY plus AZ BZ, everything divided by the magnitude of A, the magnitude of B. And theta will now be the cos inverse of this. Now, some questions, they'll ask you to find the angle between two vectors. Some questions will just ask you to find the dot products between two vectors. So now you know what to do. So moving on to our question. So we'll solve a question and then we'll see where we go from there. So for our question, we are given two vectors, A and B. So A vector is equal to 3i plus 2j minus k, and B vector is equal to I minus 4j plus 5k. So I have to find A dot B vector and also the angle between the two vectors. So what's the first thing we want to do? Remember, we know that A vector dot B vector is simply equal to AX BX plus AY BY plus AZ BZ. So 3 times 1 because AX is 3, that is the magnitude of AX, that's 3. The magnitude of BX is 1, so 3 times 1, that gives us 3. The magnitude of BY or AY is 2. Magnitude of BY is minus 4. So 2 times minus 4, that's minus 8. AZ minus 1 times BZ 5. So minus 1 times 5, that's minus 5. By the time we compute this, 3 minus 8, that's minus 5. Minus 5 minus 5, that gives us minus 10. So A dot B vector is simply equal to minus 10. Now for the other part, find the angle between them. How do we find this? Remember, we said cosine of theta must be equal to AX BX plus AY BY plus AZ BZ, everything divided by the magnitude of A dot the magnitude of B. Now, theta finally will be equal to the cos inverse of the answer we are getting here. AX BX plus AY BY plus AZ BZ is giving us minus 10. And then the magnitude of A. How do we find magnitude of A? Remember what we said for both 2-dimension and 3-dimension. Square the I, square the J, square the K, and then you get the magnitude. So what's this? So this becomes 3 squared plus 2 squared plus 1 squared. Now, the reason I'm not using this negative sign is that when you square a negative number, return a positive value just to ease the burden on our calculator. Now, I'm pressing this in our calculator. We have, so 3 squared is 9, plus 2 squared is 4, 1 squared is 1. So this is square root of 14. That's my A. So I can just write it here. So A is root 14. So dot. Again, let me clear this part so I can do the B part. So the B magnitude will then be square root of, so that will be square root of, so again, this is 1 squared plus 4 squared plus 5 squared. Okay, so 1 squared, that's 1. 4 squared, 16. 5 squared, 25. So this is equal to root 42. So this is dot 42 here. And then our theta, pressing everything here in the calculator, we simply have, so we have cos inverse of minus 10 over root 14, okay, times root 42. Okay, so our final answer here would be 114.36 degrees. So this is the angle between the vectors A and B. So I hope this principle makes sense. There's nothing difficult in it. It's just to get the or practice a lot of questions concerning this. So in our next video, we'll be looking at the vector multiplication or the cross product. So if this video has been helpful to you, always do well to subscribe, share, like, and also place a comment in case there's any feedback that's that you may want to pass across. So I'll check the description box and then get back to you. Thank you very much.